Standard on Sevilles, Eldorados, DeVille's, and Bromes is a 4-speed with overdrive automatic transmission. For 1982, DeVille's and Fleetwood Bromes offer an optional 3-speed automatic transmission with the diesel engine. In addition to adding a 4th overdrive gear, this automatic transmission incorporates a clutch torque converter for increased efficiency. In an automatic transmission, the link between the engine and the driveline is a fluid coupling called a torque converter. Essentially, a torque converter is just a series of turbine blades inside a chamber of oil. Now imagine that one of these fans is attached to the engine and the other attached to the transmission. The engine fan is powered. The other one isn't, but it turns anyway because the air from one fan turns the other, just as one turbine blade spins oil to power the other. Obviously, whether you're using air or oil between the blades, some slippage is normal. In an automatic transmission, therefore, the engine turbine needs to turn faster than the transmission turbine. That takes more fuel. But if you could hook the fans together mechanically when you had achieved your desired speed, you could eliminate this slippage. When this transmission is in 4th gear and has reached a certain speed, the torque converter engages, providing a direct mechanical link. Efficiency is increased. At identical road speeds, the 4th gear overdrive allows the engine to work about a third less in 4th gear than it did in 3rd. The overdrive gear contributes to Cadillac's impressive highway fuel efficiency. The 1982 Cimarron has a standard 4-speed manual transmission with an overdrive 4th gear, or a 3-speed automatic with the clutch torque converter is available. 2 different methods of achieving efficient use of fuel. In 1912, Cadillac was the first automotive manufacturer to equip cars with electric self-starters, lighting, and ignition. And now we have incorporated state-of-the-art electronics. If your 1982 Cadillac has digital fuel injection, you have 2 onboard computers, a primary and a backup. The digital computer that operates the system also monitors it, acting as a secretary, noting symptoms of something that may need service. It memorizes malfunctions, even if they're only temporary. It alerts you to a malfunction, even one that passes quickly, by turning on a telltale light. Check engine. If the malfunction cuts off certain information the computer needs to run the engine, the diagnostic system supplies a sensor fail-soft value, a normal value that allows continued operation of the engine. This is called value substitution. When you respond to the advice of the light and go to the dealership service department, the trained technician can sit in the car and question the computer. He or she does this by using control buttons and digital readouts normally used to control the heating and air conditioning system, the electronic climate control. By pushing the correct combination of climate control buttons, the technician can gain access to the computer. The computer verifies the contact by displaying -1.8.8 on the temperature display on the electronic control panel. The computer then displays code numbers for any malfunctions stored in its memory. The computer has 47 malfunction codes it can display. If there has been more than one malfunction, the computer displays all code numbers. Later, the computer can verify whether or not repairs were done properly. But this is only one part of DFI diagnostics, the after-the-fact part. The before-the-fact part can be even more useful. By using the system, a technician can perform a series of tests on a properly operating system as part of a normal checkup. Tests can be run on individual components without lifting the car's hood, with climate control panel lights identifying system operation. In addition to the 47 codes that the computer can use to identify malfunctions, it can provide 14 value substitutions for failed sensors, display 29 pieces of engine control information to facilitate proper servicing, and verify proper operation of 11 computer-controlled components. This is a total of 101 features for 1982. The ability of the DFI Cadillac to diagnose itself is used even before the car leaves the assembly plant. Each DFI car is linked from car computer to plant computer to report itself in and check itself out. In effect, the DFI computer is used as an onboard final inspector. The superb Cadillac, providing a quiet, smooth ride, but still with a comfortable awareness of the road as well. Over the years, saying that a car rides like a Cadillac may have been the highest compliment that could have been paid it. But in point of fact, only a Cadillac rides like a Cadillac, a product of extensive research and design, of extremely high engineering standards. Sophisticated equipment is used to test chassis components by simulating on-road conditions in a controlled situation. This helps engineers detect minute vibration and noise patterns that might not be noticed on the road. Even small fluctuations in noise and vibration that occur at specific engine speeds and under certain load conditions can be analyzed. Then, engineers can make necessary corrections on development vehicles by adding braces, for instance, that help to dampen vibration. A second, highly sophisticated test device is used to analyze the vibration of the various chassis and driveline components. Measuring and analyzing vibration characteristics of various components of the car and determining how they react to one another is essential if vibration is to be eliminated. From this and similar information, engineers can initiate changes designed to improve the Cadillac ride. For instance, as far-fetched as it may seem, a simple change in the mounting of the generator reduced vibration which could have occurred under normal driving conditions. Other changes have been made to the water pump housing and starter motor. But as much as Cadillac values sophisticated equipment, it's the human element that makes the final evaluation. Developmental cars are tested at General Motors proving grounds on a variety of road surfaces, helping to redefine problems and further establish noise and vibration priorities. Some of the components on the 1982 Cadillacs are a direct result of these efforts. For instance, the smooth power steering pump that's used on the new HT4100 DFI engine, the softer springs on Seville and Eldorado. Seville and Eldorado have also been given several refinements in the areas of mounts and braces. A new transmission mount has been developed for DeVille and Fleetwood Brougham with the new HT4100 DFI power system to help isolate noise and vibration and control road-induced shakes. Also, an under-hood sound absorber of the same density as the one used on the diesel-powered Cadillacs helps reduce the amount of engine noise transmitted to the passenger compartment. Cadillac has refined the suspension on Fleetwood Brougham and DeVille to take advantage of today's lighter engines while still retaining the Cadillac ride. The DeVille, Fleetwood Brougham and Limousine, Eldorado, and Seville have a new ISO-mount power antenna which provides an extra measure of sound suppression. The Cadillac ride. Quiet and smooth. A ride against which others should be compared. Magnificent sound. At Cadillac, it's more than just an expression. It's brilliant, sparkling highs, rich lows, and mid-range presence. Listening to Cadillac's sound systems makes it obvious you're sitting in one of the world's elegant motor cars. What makes our sound systems worthy of such an ovation? Advanced audio technology, sophisticated electronic equipment, total sound designed with your automobile in mind. In all Cadillacs, except Cimarron, electronically tuned receivers are teamed with 4 speakers, 2 in front and 2 rear. Radios and speakers that work together as naturally as woodwinds and strings. New for 1982 are extended range speakers. Standard as rear speakers on all Cadillac models, they offer highly accurate sound reproduction in a wide range of the audio spectrum. Bass response is magnificent because its foam versus paper speaker edge gives softer suspension and freer speaker travel. For great high-end frequency response, the extended range speaker has dual speaker cones. The inner cone is more sensitive to high sounds, providing high frequency response that some other speakers lack. Careful workmanship and quality materials also contribute to the extended range speaker's ability to deliver quality sound. It's important that the speaker glue be applied sparingly so it won't drip excessively on the cone, which might prevent it from moving freely in and out as it responds to the drive signal sent from the power source. The extended range speaker, another example of the quality that's built into Cadillac, one of the world's really fine motor cars. If you have a 1982 Cadillac powered by the new HT 4100 DFI engine, you also have an onboard digital computer capable of making 300,000 separate decisions a second. So it can easily handle managing the engine, doing its many electronic chores, and still have abundant thinking power left over to become your personal onboard fuel advisor, called the Fuel Data Panel. Push the first button, and the computer will tell you the rate of fuel use at that precise moment. How many miles per gallon, or how many liters per 100 kilometers, depending on the system installed. Push the button again, and it will give you the average miles per gallon, or liters per 100 kilometers, for all the roads you have driven since you last reset the device. To reset or start fresh, you push the second button. Unless you do push the reset, the computer will keep on averaging. Even turning off the car ignition won't make the computer forget. Push the third button and the computer will estimate how much driving range you have with the fuel remaining. On digital Seville and Eldorado instrument clusters, range is displayed continuously and automatically elsewhere on the cluster. Range is calculated by the computer by taking the average fuel consumption for the most recent 25 miles or 40 kilometers you've driven and multiplying that by the number of gallons or liters remaining in your fuel tank. If the estimated range remaining is less than 40 miles or 64 kilometers, the computer will display an L on the digital readout of the fuel data panel. Pushing the third button again will give you the actual amount of fuel used since you last pushed the reset button. With this feature, you can compare the actual fuel used for different routes between frequent destinations and find the most economical one for you. When you push a button, a light identifies the function being displayed. All in all, the Cadillac Fuel Data Panel is very space-age and very practical. Computer technology and a wide array of electronic equipment are integral parts of today's Cadillac, and so are the high standards of quality and reliability. To complement Cadillac's advanced technology, every gasoline-powered Cadillac is tested by assembly line computers. These computers inspect the onboard computers, certain electronic equipment, and various other systems on every Cadillac build. We call this computer testing the assembly line diagnostic link. Here, computers in the plant designed to communicate with the onboard computers in your future automobile can help determine that the automobile's key electronic components have been properly assembled and are working correctly. For Cadillac owners, the computer diagnostic link provides an extra level of assurance that their car's electronic equipment has been properly installed, thoroughly tested, and meets rigid standards for quality. The test begins after a series of visual and manual operation checks have already been completed. The engine is started and allowed to warm up so all fluids can reach operating temperatures. Then, the computer test operator connects the test head from the assembly line computer to a socket under the car's instrument panel that leads to the onboard computer. The assembly line computer interrogates the onboard computer to detect certain assembly problems that may have occurred. The operator will assist the computer by making physical checks for the car's onboard computer to respond to. The tests include such things as the climate control panel, cruise control, if the car is so equipped, and various electrical connections and sensors. When this sequence of tests has been completed, a printed readout will indicate that the car has completed testing. If the assembly line computer senses a problem, the readout will record it, and the car will be inspected and brought up to standard by an online repair specialist, then tested again. A second series of tests is then given to automobiles with digital fuel injection. Again, a test head is connected to the car's onboard computer. With wheels spinning on rollers, the operator runs the car at speeds above 50 miles per hour. As he shifts the transmission and operates the cruise control, brakes, and other equipment, a light flashes on the instrument panel. This indicates to the operator that information is being transferred from the onboard computer to the assembly line computer. A computer printout will indicate whether or not the car has passed the final inspection for quality and reliability of electronic-related equipment. Assembly line computer testing helps assure that the proper computer has been installed on your Cadillac and that related systems and components are working properly. The assembly line diagnostic link, another indication of Cadillac's dedication to technology and quality. Can brakes affect the consumption of engine fuel? Yes, they can. On a disc brake, the caliper stops the wheel by using brake pads to grip the rotor that revolves with the wheel. Unlike drum brake linings that retract away from the drum when you take your foot off the brake pedal, disc brake pads always stay in contact with the rotor. The pads constantly wipe the rotor clean and helps dry both the pads and the rotor, which is one of the pluses of disc brake design. Another reason the pads ride the rotor is that it takes more hydraulic fluid to push the large disc brake piston than it does to operate the smaller drum brake wheel cylinder. So, if the pads don't have to travel to the rotor, but just grip it harder, the brakes can apply sooner. Fine, but riding the rotor creates sufficient drag to require additional horsepower to overcome it, and horsepower requires engine fuel. So, what's been done is to redesign the system, to relax the grip of the pads on the rotor, to reduce drag on the vehicle. Part of the redesign is a modification of the piston seal groove. It allows the seal, which acts as the piston retracting springs, to retract further when the brakes are released. A new master cylinder, called a quick take-up master cylinder on gasoline-powered cars, is capable of moving a greater quantity of brake fluid to the disc brake piston and retrieving the added fluid quickly when the brakes are released. On diesel-equipped cars, the HydroBoost master cylinder has a larger brake fluid capacity to compensate for the greater flow. The end result is reduced brake drag and less engine power required to overcome the drag. The 5.7-liter diesel engine, optional on all Cadillacs except Cimarron, offers the kind of fuel economy and performance you can appreciate in today's full-size luxury car. But the 5.7-liter diesel is still undergoing changes. A recent refinement, for instance, is the inline fuel heater. The paraffin or wax found in diesel fuel tends to thicken in temperatures below about 15 degrees Fahrenheit, 10 degrees Celsius, and block the flow of fuel from the fuel tank to the engine. It's a lot like the hot wax that drips from the side of a candle. As the wax cools, it hardens. In a diesel engine, the thinner the fuel is, the easier it flows through the fuel line and the injectors. That's why the 5.7-liter diesel has a fuel heater that automatically warms the fuel in cold weather. This allows the fuel to flow normally to the engine, contributing to impressive cold weather operation. The diesel fuel line heater. Another reason why the 5.7-liter diesel from Cadillac is such an attractive proposition. Over the years, Cadillac owners have been both attracted to and become used to being pampered by Cadillac's traditional blending of style, elegance, and advanced technology. Often it's the more subtle features that gain the attention and praise of the Cadillac owner. In 1981, it was the miles per gallon readout, the MPG Sentinel, and the memory seat. For 1982, the outside temperature display system uses microcomputer technology to provide an accurate display of the outside temperature. The system uses a carefully calibrated, protectively shielded, and very accurate temperature sensor. To call up this display, all you have to do is push the outside temp button on the electronic climate control panel. This will signal your car's onboard computer to process the information picked up by the sensor and relay this information to you on the panel. The system is programmed to minimize exaggerated temperature variations resulting from heat buildup in city traffic and idle conditions, for instance, when you're stopped at an intersection. At normal speeds, no compensation should be needed. Pushing the outside temp button will not disturb any of the other electronic climate control settings because it operates independently. Owners of those Cadillacs which can be equipped with the optional digital instrument panel can switch their temperature display from degrees Fahrenheit to degrees Celsius. On other cars, this readout is pre-selected at the factory for either Fahrenheit or Celsius. Another small but important convenience touch that the Cadillac owner has every right to expect.